Today we're going to learn about the aircraft equation of motions, and the content which we are sharing over here is about the understanding Euler angles, and the other topics will be discussed later on in the other videos. The first topic is about the understanding the Euler angles and how we go about it. Before understanding Euler angles, a reminder to consider four quadrants and right hand rule. These are the four quadrants. The first one is on the right hand side, which is shown with the blue color, and then on the left hand side, the upper left hand side, we have got the two positive, where there was sine theta positive and the cosec theta positive. uh, and then we come to the third quadrant, which is the 10, where the tan theta and the cot theta is positive. And then ultimately we come to the fourth quadrant, where the cos theta and the sec theta are positive. And within the first quadrant we have got all the trigonometric identity positive. So now, to understand the Euler angle, the best way would be to Euler angle are simple and intuitive, and they will simple be used for the control analysis. On the other hand, Euler angles are limited by phenomena called gimbal law. This gimbal law, which will be investigated in later applications. So what we will be seeing is that whenever the gimbal law takes place, so the operation of the pitch is hindered at specifically on the very topmost angle, either in negative side or on the positive side of the 90-degree. Then if you go further, you will see inertial frame of reference, and within the inertial frame of reference we have got three axes on which the aircraft rotates. One is the x-axis, second is the y-axis, and third is the z-axis. For us, when it rotates with respect to z-axis, so at that time it is creating an angle called psi, which is basically changing the yawing angle. And then when it rotates with respect to x, it is changing its pitch angle, which is shown with the green color over there on the screen. And then ultimately, when it rotates by the y-axis, that's shown with the phi, which is a roll angle. So there are three angles induced due to the roll, pitch, and yaw of the aircraft. So over here, the yaw angle, which is psi, is shown with the blue color. Theta, which is a pitch angle, shown with the green color, and red, which is the phi roll angle, ultimately. So now what we have learned today is that we've got to know that there are three angles which will be playing around in the complete understanding of the Euler phenomena. And then furthermore, if you go for convenience, we use multiple coordinate frames to describe the orientation of the sensors, including the inertial frame, the vehicle 1 frame and the vehicle 2 frame, and ultimately the body frame. The inertial frame axes are mostly representing the earth fixed axis, and the body frame axes are aligned with the sensors, so they are mostly aligned with the sensors. So with the movement of the sensors, the body frame references do uh, change. Vehicle 1 and the vehicle 2 are the intermediary frames used for the convenience when illustrating the sequence of the operation that takes us from the inertial to the body frame. So while you're changing from the inertial to the body frame, you use a vehicle 1 frame or either vehicle 2 frame. So ultimately, this ends up our first part, and second part we will start in the next lecture, and that is related to the inertial frame and the formation of the rotational matrix or direct cosine matrix. Hopefully, we will start that in the next video.